Good morning, my dear students. In this video presentation, again, we will discuss some more problems meant for class 12 of CBSE. The first problem meant for today is from probability. It is application of Bayes theorem, but it's totally a different problem. Try to understand the problem. Such a problem may be given in your board examination. But if you apply your mind, it is as easy as any other problem. Okay, the question goes like this. A box has 5 balls. 3 balls are chosen at random and all the 3 are found to be red in color. What is the probability that all the 5 balls in the box are red in color? Let me repeat. A box has 5 balls. 3 balls are chosen at random and all the 3 are found to be red in color. Find the probability that all the balls in the box are red in color. All the 5 balls are red in color. Just see the situation here. It's not a difficult process. Let E1 be the event of having 3 red balls, 2 non-red balls in the box. Let E2 be the event of having 4 red balls, 1 non-red ball in the box. Let E3 be the event of having 5 red balls in the box. 5 red balls in the box. Let E be the event of choosing 3 red balls. These are the assumptions, let us say. Now P of E1 is equal to P of E2 is equal to P of E3 is equal to 1 by 3. Those are 1 upon those 3 possibilities. Now P of E bar E1. This first possibility is considered, from which I am choosing 3 red balls. Therefore, there are 3 red balls, 3C3 by 5C3, which is 1 by 5 into 4 into 3 into 1 into 2 into 3. Here 3 gets cancelled. It will end up with 1 by 10. Now P of E bar E2. The second possibility is chosen. The second possibility is chosen. Okay, second possibility is there, and I am having 3 red balls. There are 4 red balls here. 4C3 by 5C3, which is equal to 4 by, this reduction is 10, we have seen just now. I can use it as it is. Now, just for calculation purpose, I have 10 as it is in the denominator. P of E bar E3. This is 5C3 by 5C3. The third possibility, I am choosing 3 red balls. All of them are red. Okay, 5C3 by 5C3. Okay, therefore I mean to say this is 10 by 10. I can have 1 is nothing but 10 by 10. Now E1, E2, E3 are mutually exclusive and exhaustive. Therefore, Bayes theorem is applicable. Bayes theorem is applicable. Okay. Now P of E is equal to P of E1 into P of E bar E1 plus P of E2 into P of E bar E2 plus P of E3 into P of E bar E3. This result is called total probability theorem. Total probability theorem, by total probability theorem. This will be anyway 1 by 3 into 1 by 10 plus 1 by 3 into 4 by 10 plus 1 by 3 into 10 by 10. I have the common denominator 30. Therefore, I will get 1 plus 4 plus 10, which is 15 upon 30. Now, required probability is equal to required probability is equal to P of E3 by E. I am having 3 red balls, and what is the probability? All the balls are red in color. Therefore, third possibility is my numerator. Therefore, this is P of E3 intersection E by P of E, which is P of E3 into P of E bar E3 by P of E. Let me substitute the values. What do I end up with? 1 by 3 into 10 by 10 by 15 by 30. Now only the reduction part, where should I write? It should be visible. Let me write here the final step, which is reduced to 10 upon 15, which is 2 by 3. Answer is 2 by 3. Let me explain the whole lot. I assume E1 be given to having 3 red balls. The remaining 2 balls, it can be of any color. I am not bothered. White or blue or whatever it may be. 2 non-red balls. E2 be given to having 4 red balls, 1 non-red ball. And E3 be given to having 5 red balls in the box. Let E be given to choosing 3 red balls. Now P of E1, P of E2, P of E3, all the 3 are 1 out of those 3 possibilities, 1 by 3. If E bar E1, from the first possibility I am choosing 3 red balls. There are 3 red balls, 3C3 by 5C3. 1 by 5 into 4 into 3, 1 into 2 into 3, which is reduced to anyway 1 by 10. If E bar E2, from the second possibility I am choosing 3 red balls, 4C3 by 5C3. I think bottom portion is not visible here. Let me just 1 second. Okay, you mean to say 4 by 10. This reduction is 10 we have seen. Now P of E bar E3, all of them are red. So sure even. 5C3 by 5C3, 10 by 10. E1, E2, E3 are mutually exclusive and exhaustive. That is, if E1 happens, E2 won't happen. There is no common element between out of those 3. That's the reason why I call it as mutually exclusive. 1 by 3 plus 1 by 3 plus 1 by 3 is 1. Or E1 union E2 union E3 is yes. That's the meaning of exhaustive nature. Therefore, Bayes theorem is applicable. Now P of E can be written like this. This is by total probability theorem. 1 by 3 into 1 by 10 plus 1 by 3 into 4 by 10 plus 1 by 3 into 10 by 10. 14 plus 1 is 15. 15 by 30 becomes, let it be as it is. Now I am having 3 red balls. What is the probability? All the balls are red in color. Therefore, E3 bar E is the required probability. Just cross multiply P of E bar E3, the condition. P of E3 intersection E by P of E3. Cross multiply, I will get the numerator. 1 by 3 into 10 by 10 into 15 by 30. 30 gets cancelled. I am writing the final answer here. 10 by 15, 2 by 3. Now, this question is similar to, listen to what I am telling you. I am going to tell you carefully. If there are 3 boxes, box A has 3 red balls, 2 non-red balls. Box B has 4 red balls, 1 non-red ball. Box 3 has 5 red balls. One box is chosen at random and 3 balls are chosen from it. And all the 3 are found to be red in color. What is the probability chosen from box C? That is given in a different way. Let me repeat. Box A has 3 red balls, 2 non-red balls. Box 3 has 4 red balls, 1 non-red ball. Box C has 5 red balls. One box is chosen at random and 3 balls are chosen from it, and all the 3 are found to be red in color. What is the probability is chosen from box C? That particular question is given in a different way here. There again, P of E1, E2, E3. Out of 3 boxes, I am choosing 1 by 3. The rest of the answers will be as it is, the same manner it will go. Now, for instead of giving it as 3 balls in 3 different boxes, it is given in a shorter way. Now, for understand the logic behind this question, it is not at all difficult. Understand the logic behind this question. It's very simple. If such a situation is given with a different number and different colors of balls, etc., don't leave out the question. Understand and then do in your board examination. Understand and do your board examination. Just I'll take one more example quickly. A vector not equal to 0 vector, B vector not equal to 0 vector. Then I need to prove a result. A plus B dot A plus B is equal to mod A square plus mod B square, if and only if A vector is perpendicular to B vector. I repeat, A vector not equal to 0 vector. Okay, B vector not equal to 0 vector. Then A plus B dot A plus B is equal to mod A square plus mod B square if and only if A is perpendicular to B vector. Proof is very simple. Let me initially assume A plus B dot A plus B is equal to mod A square plus mod B square. Let me apply distributive property in LHS. A dot A plus A dot B plus B dot A plus B dot B is equal to mod A square plus mod B square. A dot A plus A dot B plus B dot A can be written as mod A square plus 2A dot B plus mod B square is equal to mod A square plus mod B square. These two will anyway get cancelled, which will imply you twice of A dot B is equal to 0, which implies A dot B is equal to 0 by 2 is equal to 0, implies A vector is perpendicular to B vector. Okay, conversely, let A vector perpendicular to B vector. Now A dot B is equal to 0. Therefore, now let me try to simplify A plus B dot A plus B. Here I mean to say, again apply distributive property. A dot A plus A dot B plus B dot A plus B dot B, which is equal to mod A square plus 0 plus mod B square, which is equal to mod A square plus mod B square. I am able to prove this result. Therefore, in both ways the result will be true. Let me just explain once again. A vector not equal to 0 vector, B vector not equal to 0 vector. I need to prove A plus B dot A plus B equal to mod A square plus mod B square if and only if A is perpendicular to B vector. If and only if means when this is assumed, this should be proved. When this is assumed, this should be proved. That's the meaning of if and only if property. A plus B dot A plus B is equal to mod A square plus mod B square. Let me assume this. Let me apply distributive property. A dot A plus A dot B plus B dot A plus B dot B is equal to mod A square plus mod B square. A dot B is the same as B dot A, therefore it becomes twice of A dot B. Dot product is commutative. A dot A is mod A into cos 0, therefore mod A square. B dot B into cos 0 degrees. Therefore mod A square gets cancelled, mod B square gets cancelled. Twice of A dot B is 0, A dot B is 0 by 2 0. Therefore A dot B is 0 means A is perpendicular to B vector. Conversely, A is perpendicular to B vector. Now A dot B is 0. A plus B dot A plus B. Apply distributive property. A dot A plus A dot B plus B dot A plus B dot B. A dot B is 0, S plus B dot A is also 0. Therefore, this becomes 0, this becomes 0. This becomes mod A square, this becomes mod B square. It's reduced to mod A square plus mod B square. Therefore, I come to the conclusion A plus B dot A plus B is equal to mod A square plus mod B square. If and only if A vector is perpendicular to B vector. It's a very standard result. It's not at all difficult. I'll check for the calculations like as usual. If there is no correction, I'll upload as it is. Thank you students for patient watching.